Good morning, students. We had a little bit of a lack of enthusiasm this fine morning, but it was eloquently put forth that perhaps a later starting time or something like that might be useful. Here's what I'm going to try out for you guys. Recording today's lesson. You can watch it whenever you like, as long as you do it before our Wednesday class, and of course with enough time to do the homework. So let's jump right into it. I am going to need some audience participation, so don't be creeped out and think it's super weird when I am my own audience. So here we go. We're going to jump in and develop a new theorem. So like any other proof, I am starting with the givens. Don't forget to number your proofs. So 1 and 1. My first reason is always the given. My given is that angle A is sup to angle B, and I can put it in a different line but the same number because it's the same reason, or I could give it its own number. It doesn't really matter. Angle C is sup to angle B. I'm just going to say that that is all step 1. In step 2, I'm going to say that the measure of angle A plus the measure of angle B equals 180 degrees. And for the same exact reason, I can say that the measure of angle C plus the measure of angle B equals 180 degrees. And that reason is if two angles are supplementary, then the sum of their measures is 180 degrees. A very good definition of what it means to be supplementary. Now, from an algebraic standpoint, what would happen if I were to subtract these two equations from one another? Then I would get the measure of angle A minus the measure of angle C plus the measure of angle B minus the measure of angle B. Ooh, those would kind of go away. Equals 180 minus 180 equals 0. And with a little bit more algebra, I could show, if I added the measure of angle C to both sides, that the measure of angle A is congruent to the measure of angle C. You shouldn't say is congruent to a measure. The two measures are equal. Step ahead of myself there. How I would state this in an if-then is a little bit, awkward. If you have two algebraic equations, then you may manipulate them algebraically. It's not going to be an issue. I'm just going to say some algebra. Why do I not care? It's just not going to come up. But well, what do we say about two things which have the same measure? I can now say that angle A is congruent to angle C. Of course, that's what I was trying to prove. My reason would be if two angles have the same measure, then they are congruent. And that is our definition of congruency. It gets us where we need to go. Okay, well, remember theorems are shortcuts. So basically, anytime I have this situation, I can end up with this situation. Now we have to be able to say those situations more generically. I don't want to say, oh, if angle A is supplementary to angle B and angle C is supplementary to angle B. If two angles are sup to the same angle, then they are congruent. So that is our newest theorem to join our ever-growing list of theorems. The next time we meet, by the way, I think it's the next time we meet, we have to learn 8 of them. So quite a lot, but it's not that bad. because frequently once I have a theorem, I usually end up with very similar theorems. I can change one word and get another theorem out of this. Two angles are supplementary to the same angle, then they're congruent. Well, what did we learn about yesterday? Supplements and complements. Oh, hey, how about following this and getting if two angles are complementary to the same angle, then they are congruent. Now, what I'd like to do is I'd like to do this same proof, this one over here, but in a very different way, not in a two-column proof or anything like that, in just a kind of weird, hey, let's see if this makes sense. So what I often do is I ask someone in the audience, and I say, what angle would you like to make angle 5? How big does it look like to you? And someone will wisely say something like, oh, it looks like 20 degrees. It would be wonderful. Let's make it 20 degrees. And it's given information that angle 5 is complementary to angle 6. So how big does that make angle 6? Remember, complements make a 90-degree or right angle. So if that's 20, this one has to be 70. And then I say, okay, well, look, angle 7 is complementary to angle 6. So what's complementary to 70? 20 degrees. And I look, oh my goodness, amazing. Those two angles have the same measure, and therefore they are congruent, angle 5 and angle 7. And then I look at whoever said that 20 degrees, and I go, 20 degrees? 20, I'm sorry, I wasn't paying attention when I said okay to 20 degrees. That's nowhere near 20 degrees. Just, I don't know who that was, who raised their hand and told me 20 degrees. You're just being silly. Could someone please raise your hand and tell me what angle it really is, what it really looks like? And sheepishly, someone usually raises their hand, says another number, and maybe it's 22 degrees this time, and this one would have to be 68 degrees. This one is complementary to 68, and so it would have to be 22 degrees. And of course, the angle 5 and angle 7 are still congruent. And, I keep this up for a little while. 22 degrees, are you kidding me? How did you get into the school? 22 degrees. And we cross it out. We try a few more examples. And eventually we say, okay, what am I trying to say? We don't really know what this measure is, so let's call it X. This one, well, what's the complement to X? It is 90 minus X. And yesterday we did that one awkward thing where it said, what is the complement to an angle whose measure is given as 90 minus X? And we decided it was X, but this time I'm gonna show it. I'm gonna say, anytime I find a complement, I take its value and I subtract it from 90. So we've got 90 minus the quantity of 90 minus X. 90 minus 90 is 0, and when I distribute that negative sign, I end up with an X. And if that has a measure of X and that has a measure of X, then they've got to be congruent. So we've really shown this theorem that if two angles are complementary to the same angle, then they are congruent. Okay, let's see it in, not quite the same theorem. As I said, very frequently we can just change a word or so and get a new theorem. So let's take a look here what we have. Angle 1 is up to angle 2, and angle 3 is up to angle 4, and angle 2 is congruent to angle 4, and 1. All this stuff is given. So in step 2, I'm just going to cut to it. Not going to do those algebra steps again. But, well, if angle 1 kind of looks like 60 degrees to me, angle 2 would have to be 120 because it's supplementary. Angle 2 is congruent to angle 4, so angle 4 has to have the same measure, 120. And what's supplementary to that? 60 degrees, and needless to say, 60 and 60 are congruent. This is where I would yell at someone and go, 60 degrees, are you kidding me? Are you blind? That's not 60 degrees. You can put whatever you want. You can put half a degree. And so this one would have to be 179 and a half. This one is congruent. So 179 and a half, and what's supplementary to 179 and a half would be half a degree. So yes, those two things would be congruent. Our theorem this time, which gets angle 1 congruent to angle 3, this isn't really a proof of the theorem, this is just me using it, is if two angles are not to the same angle, not to each other, but to congruent angles, then they are congruent. And state of the theorem that was proved above. Again, I did not use the worksheet as they intended. I didn't prove it. I didn't put in that awkward algebra step. But we're saying if two angles are sub two congruent angles, then they are congruent. Okay. We're 3 out of 4. We just have one more permutation of these slightly different arrangements of words. Without even spending too much time looking at it, we can guess if two angles are to the same. No, in this case, two congruent angles, then they are congruent. Just to be clear, angle 5 is complementary to angle 6. This looks maybe like 10 degrees. So that one would have to be 80 degrees. Angle 5 is congruent to angle 7. Angle 5 is congruent to angle 7. So this one would have to be 10 degrees as well. Angle 7 is complementary to angle 8. So angle 8 is going to have to be 80 degrees again. And all of a sudden, 6 and 8 seem to have the same measure there. And of course, I could really call this x. This would be 90 minus x. This would be x because it's congruent. That would be 90 minus x. And of course, 90 minus x and 90 minus x are the same measure. They are congruent to one another. Okay. Here is where we get to actually practice this. So we're given the diagram and that angle 3 is supplementary to angle 1. So I'm going to write both of these things. I'll squeeze them into a single line. Diagram, I happen to like semicolons, and angle 3 sub angle 1. And 1, all that information is given. Notice I am numbering my steps. I am putting them on even lines, all that good stuff. Okay. Well, what kind of things can I assume from diagrams? I can assume straight angles, and if angle 1 and angle 2 form a straight angle, then they are supplementary. As mentioned yesterday, I like to do that in a single step. So I'm going to do that. I'm going to say angle 1 is sub to angle 2. And in my opinion, you can go right from a diagram to that. And the reason will be if two angles form a straight angle or line, I don't care, then they are supplementary. Okay. I realize I'm bending the rules ever so slightly. The if part is what I'm already supposed to know. Nobody mentions straight angle. I'm the one writing this class as we go, or at least proctoring this class as we go. And I say if it's something that you can assume from the diagram, I don't need it written down ahead. I don't need the step. You're welcome to put it, but I don't need the step which says that angle ABC is a straight angle assumed from the diagram. Okay, so now I have 1 sub to 2, and they told me that 3 was sub to 1. Oh, okay, this seems to be using our previous theorem to say that angle 3 and angle 2 are congruent. Angle 3 is congruent to angle 2 is what I am trying to prove here. I will do it by saying 3. If 2 angles are, well, in this case, they're both supplementary, sub to each other, no. To the same angle, yes. To 2 congruent angles, not that I know of, are sub to the same angle, then they are congruent. There we have it. A is really going to be very useful because A is going to be helping us to do the second task for today. The second task for today is to cover section 2.8, which has one theorem. It's one super easy theorem, and we're really going to prove it right here. So angle 1 and angle 2 are opposite one another. They are formed from opposite rays. The ray BC and the ray BA are opposite one another. BE and BD are opposite one another. Excuse me. Those angles are called opposite angles, or the book calls them vertical angles. Sometimes I will refer to them when people are having a hard time with this theorem as scissor angles, because when you close the blades of a scissors, close the handles of a scissors, the blades close as well, and when you open them, they open as well. They really do the same thing. So here we go. I'm going to say that angle, I should start with my givens. 1 diagram. 1 given. In step 2, I'm going to say that angle 1 is sub to angle 3. And 2, I'll say if 2 angles form, last time I said straight angle, this time I'm going to say line, form a line, then they are sub. Let me see that. Nope, there we go. If 2 angles form a line, then they are sub for the exact same reason, so you can put it in the same step, even though it's technically on a different line. I'm going to say that angle 2 is sub to angle 3. Okay, same reason. I don't need to put in another reason. We're still in step 2. Now, oh, wait a second. Angle 1 sub to 3, angle 2 sub to 3. Angle 1 must be congruent to angle 2. 3. If 2 angles are sub to the same angle, then they are congruent. And I'm going to pause right here and say we can do that proof even shorter. In fact, this is one of those uber rare proofs I could do in a single step very frequently. We're going to leave aside this diagram as shown bit fairly soon. They like to just get you in the habit of writing something in the place of givens, even if it's just diagram as shown. But at some point, we're going to quit doing that. And we can just use our brand new theorem because angle 1 and angle 2 are opposite angles or vertical angles. Our brand new theorem, which says if angles are vertical, then they are congruent. Now, I have seen people who have spent a lot of time reading the book, and the book, for some reason, writes this without the if and the then. The book is not grading your quizzes and tests. I am. Please put the if and the then in there. So even if you've read the book and are getting slightly different advice and information, please do it this way. Okay, let's continue on. I am going to pause the video, give you guys a chance to do this one. I am going to do it as well. And I'm going to give the same treatment to number 4, and you're just going to see the answer so you can compare. Okay. Okay, so I kind of lied here. I didn't quite finish the proof. I filled in some statements and thought we'd do the reasons together. Needless to say, the first one was given. Well, then I needed to say that angle ABC was right, or perhaps I could have gone 90 degrees. It still could have worked. I just would need to word things a little bit different. How do I know that it is right? Because, oh, hey, look, those segments are perpendicular. If two segs are perpendicular, then they form right angles. Well, this is a right angle, and I'm going to mark it on the diagram. This is a right angle that was given. And now that they're both right, I can use the exact same reason to get angle 1 complementary to angle 2 and angle 3 complementary to angle 4. If angles are right, then they are formed by complementary angles. It's awkward. I think I would have said if two angles form a right angle, then they are complementary. But it works. The if part is what I already know. They are right. The then part is what I am trying to show, complementary. And now angle 2 is congruent to angle 4 by one of our theorems. It's clearly one of the ones involving complementary. Are they complementary to the same angle? No, it doesn't say that. They're complementary to congruent angles. Angle 1 and angle 3 are congruent to one another. So if two angles are to congruent angles, then they are congruent. Okay. Very similar proof for problem number 4. Same treatment. Okay, almost identical to what we had before. I got that we have two pairs of supplementary angles using my theorem, which says if two angles form a line, then they are supplementary. Yes, more of a definition than anything else. And now I can say if two angles are not to each other, but two congruent angles, then they are congruent. Takes me from what I know to what I am trying to show. Beautiful. Let's take a crack at this C-level proof. Now, C-level proofs, today's C-level proof is tomorrow's B-level proof, and next week you would consider this an A-level proof. So I do want you to try it on your own again. I am going to pause the video and fill in some stuff. And let's meet up. If this one seems a little bit trickier, again, it's supposed to. It is a C-level. If you look back at it in a day or two and still think it's complicated, that's where I would start to work. Okay, here's what I have so far. Not many steps, but a little bit different that we're not finishing up with one of our new theorems. So we don't have a theorem that we learned today, which proves that something got bisected. So I listed all my givens. I also marked them as congruent, that angle C and that angle A. Perfectly fine, call it C and A. There's no other angle which those could be. Well, C is comp to CBD. A is comp to ABD, and since they are congruent to one another, their complements must be congruent to one another. So if two angles are comp to congruent angles, the two angles I'm talking about here are CBD and ABD. They are comp to congruent angles. Those two angles are angle C and angle A. Then they, the two original angles, these two, are congruent. Great, and I'm gonna mark them as congruent, that guy and that guy. Oh, hey, it looks like a bigger angle just got split into two congruent angles. Well, that's what it means to bisect. So in 3, I'm gonna say if an angle is split into congruent angles, then it has been bisected. You could also have said, if a ray splits an angle into congruent angles, then it is a bisector. Either way, I think we are okay. Well, let's see if they lined up 2.8 right after this. Nope, they got a little bit of review stuff. All right, let me pause and get this on. Okay, jumped ahead to page 39 here, where we're setting up what looks kind of familiar because we saw something very similar to it before. And this is a proof that the vertical angles 1 and 3, sometimes people look at me strange when I call them vertical angles because they seem to be horizontal from one another, but it doesn't matter whether it's this way or that way. They're still called the vertical or opposite angles. So diagram as shown, of course, that is given. They went the step and said ABC is a straight angle, which we are allowed to assume from diagram, but we're also allowed to skip that step. 3, angle 1 is sub to angle 2. Here is where I say if two angles form a straight angle, which is what they called it, then they are supplementary. Didn't really give me enough room to write there, but that's okay. Works for me. Angle DBE is a straight angle. I'm going to say in step 4, same as number 2, same as step 2. I think it's tricky when you can do that. I think it's just insane and kind of fun when you get to say things like converse of step number 3 or something. That's really cool. Why is angle 2 sub to angle 3? Well, this is the same as number 3. Quite frankly, I would have put step 2 and 4 in the same step. They have the same reason. I didn't need to learn anything in between knowing that ABC is a straight angle and learning that DBE is a straight angle. And then I could have put 3 and 4 in the same step and really shortened this up quite a bit. Well, why is angle 1 congruent to angle 3? That is where we get to say if two angles are sub to the same angle, then they are congruent. And this shows us that vertical angles are always congruent. This is true anytime I have vertical angles. Everything that we saw here is true of all vertical angles. Write it in if-then form. If angles are vertical, which I just spell vert, boop, there, then they are congruent. Okay. And that's it. We can do problems with that where we say, oh, well, these two angles are vertical, therefore they are congruent, therefore we can set their measures equal to one another. Just a little bit of simple algebra there. But if someone asked me, they set up this proof, just like up here, and asked me now that we know this theorem to prove angle 1 is congruent to angle 3, I would have made it a one-step proof, the rarest of the rare, that one-step proof. If two angles are vertical, then they are congruent. Vertical angles is something that you can assume from a diagram. You don't have to tell me the diagram as shown. You don't have to tell me in another step, if angle 1 and angle 3 are vertical, how did I know it? It's assumed from diagram. I can see that they are vertical angles. Just skip to it. Angle 1 and angle 3 are congruent because they are vertical. If two angles are vertical, they are congruent. Also, angle 2 and angle ABE, B is a point, so we can't really call it angle B. Angle 2 and angle AB are congruent because they're vertical angles. If angles are vertical, then they are congruent. Simplest theorem of presumably the year, this vertical angle thing, and done. All right, you guys know where to find your homework. Have a good Tuesday, it should be.